With this lesson, you're going to use properties of equilateral and isosceles triangles to find missing angle measures. You learned in the first page of day 2, to identify triangles by their angle measures. We call them right, acute, or obtuse, and also to identify them by their size, equilateral, isosceles, and scalene. These triangles are identified by their size. Equilateral triangles have sides that are congruent. So I would make angle markers here. Congruency markers rather. Notice they all have one marker. That's because every single side is congruent to each other. So let's write some notes. All angles in a triangle add up to, all angles, I'm tripping over myself, add up to 180 degrees. Now I also told you about angles opposite sides. Well, in an equilateral triangle, you have 3 equal sides. You also have 3 equal angles. So what would the measure of those angles be? 60 degrees, because they're congruent, and 180 divided by 3 is 60. So in an equilateral triangle, every single angle is 60 degrees, and every single side is congruent. Now we're going to look at an isosceles triangle. Those two sides are congruent. It has 2 equal sides and 2 equal angles. They have the same measure. Remember how I showed you that goes with that, and that goes with that. So you're going to use those properties. Now let's play. Well, this is an equilateral triangle. Actually, we can say it's equiangular. Why? Because we know this angle is congruent to this angle, is congruent to that angle. See, we have measurements. They're all the same. So that means the triangle is equilateral. All 3 sides are going to be the same. So side AB is going to be 4. This is 4, and this is 4. See how I did that? I used the properties at the top of the page, properties for an equilateral triangle. All 3 equal sides, 3 equal angles. And I looked down here and I saw this triangle has 3 equal angles, therefore all 3 sides are congruent. Now let's do this one. We have congruency markers here. So that means these 2 angles, angle D and angle F, are congruent. But how do we know the measurement? Well, you go back to that statement in black. All angles add up to 180 degrees. So we take 180, we subtract the amount of the one angle we know, which is 100 degrees. We have 80 degrees left, and we have to split it between 2 angles. So each angle is 40 degrees. Let that sink in. Now, example 3, we're going to find the measure of angle X. And as I said so many times before, draw this and mark it up. We know these sides are congruent. Therefore, angle Y is congruent to angle W. Well, angle Y is 40 degrees, so what's the measure of angle W? It's also 40. Those 2 add up to 80. 180 minus 80 equals 100. Angle X is 100 degrees. You are applying what you know. It's not just fill in one blank. You have to apply. You have to recognize what the markings mean. You have to recognize which type of triangle we're talking about and how to fill in the rest. All right, next page. Now we're going to talk about line segments inside a triangle. There are some properties, and they will show up in proofs. So let's talk about the first one. A segment, ray, or line that is perpendicular to a segment at its midpoint. I'm going to highlight that. I'm not going to highlight it that way. Perpendicular to a segment at its midpoint. Notice YV is congruent to XV. So this would be the perpendicular bisector. Why? Why is it called that? Because YX is bisected and WV is perpendicular to YX. See that right angle marker? So, like we do so much in geometry, we call it what it is. It is perpendicular and it bisects the side. It is a perpendicular bisector. All right, now let's do another one. Highlight it. That divides an angle into two congruent angles. So now let's look at what this is. We call this an angle bisector. Because angle YZX is bisected by VZ. Angle YZV is congruent to angle XZV. See the congruency markers? It is bisected, cut in half. So we call it what it is. No fancy words. Alrighty. Now, the next one. This is a segment that connects a vertex to the midpoint of the side opposite the vertex. Okay, vertex is the point in a triangle. We call this the median. So we can say AD bisects BC. But it is not perpendicular to BC. It simply bisects it. The median, you know what a median is. It's like in the middle of the road, the thing that you shouldn't drive over. That's what it, so this bisects it. It is the median of the triangle. Last definition. This is a segment that connects the vertex to the opposite side. Vertex and is perpendicular to the side of the opposite. To that opposite side. I'm tripping over myself again. This is the altitude of the triangle. What we can say is GI is perpendicular to FH. There are no congruency markers, so it does not necessarily divide FH in half, but it is perpendicular. Now this one is kind of fun. Honestly, it is. We know that the sum of the interior angles of a triangle is 180 degrees. So this is like a gift of a question. How do you determine if those three angles in each row can be the measures of a triangle? You add them up. They must equal angle measures must add up to 180. It's that simple. Okay, so I'm going to get my handy dandy calculator out. 75 degrees plus 20 degrees plus 85 degrees equals 180 degrees. So they can be measures of a triangle. Well, 28, 21, and 41, I know the answer is no, but I want to see what the exact measurement is. That only adds up to 90 degrees. Cannot be angle measures of a triangle. You have to add up to 80. Okay, 18 plus 120 plus 42 equals 180. Can be measures of a triangle. Then 47 plus 53 plus 44 add up to 144. Cannot be measures of a triangle. That's all you have to do. You're welcome.